So on page 13 in your packet, there's a sheet that says Bonding Basics Practice. And so that's what this is going to go over. We're going to talk about how to model ionic and covalent compounds with bonding. The first set has to do with ionic compounds. And so for ionic compounds, we are talking about bonds between, we're talking about bonds between metals and nonmetals. And these are going to be where they transfer electrons. Okay, transferring electrons. So if you look at the first set of elements, you've got magnesium and bromine. The first thing you want to do is you want to go in and you want to do the Lewis dot structure for each one of them. Magnesium is Roman numeral 4, and bromine is Roman numeral 7. So those are the valence electrons. Now, if I look at what's happening between these two, I can see that magnesium has 2 electrons to give away, and bromine can only accept 1, because once it accepts that 1, then its valence shell is going to be full. It will have an octet. So what I'm going to do is I'm going to need to have 2 bromines. And when I do, that's going to give me a 1:2 ratio. And when I draw that out, I'm going to redraw it over here to the right. Magnesium and then bromine. I'm going to have 1 bromine and another one. And I know the reason I need 2 is because I've got to take 1 electron over here, and I've got to take this electron over here, because bromine can only take 1. And then when that happens, the magnesium loses the 2 electrons. And at that point in time, magnesium becomes a cation, which has a positive 2 charge, because that's how many electrons it lost. And bromine, I have 2 of them, and that would be a negative 1 charge. Each bromine gained 1 electron. So this is just showing you what's happening in my compound. And I can even put a plus sign there if I want to. And so my compound formula, after everything is said and done, is going to be MgBr2. So that's how we do ionic bond models, practice models. If we look at number 3 is aluminum and chlorine. So aluminum off the periodic table is Roman numeral 3, so it has 3 electrons. Those are 3 horribly placed electrons. Let's fix that. 1, 2, 3. Chlorine, if I look at it, it has 7 electrons, which means that chlorine can only take 1 right here. And aluminum has to get rid of 3, so I'm going to need to have 1 of these, and I will need to have 3 chlorines to take all those electrons. So redraw my model. Aluminum and chlorine. I'm going to go 7 electrons for each chlorine. These guys are not sharing electrons. So this electron's going down here, 1 electron's here, and 1 electron's here, which means my aluminum is losing its electrons. So I end up with Al with a positive 3 charge, and Cl, 3 of them with a negative 1 charge each. That gives me AlCl3. So that's how you do ionic compounds. Now, for covalent compounds, those are a little bit different. If I look at a covalent compound, I'm talking about nonmetals plus nonmetals. And these are sharing their electrons, so there are no charges. Do not put charges on anything. No charges. If I look at H plus Cl, hydrogen has 1 electron and chlorine has 7. So that means that they are going to need to share this pair of electrons, and I draw that by a line between the two representing a bonded pair of electrons. And that gives me 6 electrons out here for chlorine, plus my 2 shared electrons here gives me 8, and that gives me 2 for hydrogen. So my formula is HCl. You notice I didn't write that it gained or lost any because they're not gaining or losing, they're just sharing with each other. If I look at number 2, I've got carbon and chlorine. Carbon has 4 electrons. And we know that carbon likes to be the center of attention, likes to be in the middle of compounds because it can easily make nice 4 bonds here. Chlorine has 7, which means it only needs to make a single bond, okay, to share its electrons. So I'm going to put my carbon in the middle, and it is going to share its 4 electrons with chlorine. Each chlorine is going to share an electron, which leaves the other 3 pairs out here unshared. So my ratio for this is a 1:4 ratio because I need 1 carbon for every 4 chlorines. So it's CCl4. And then the last example on that page is silicon and oxygen. And if I have silicon, silicon has 4 electrons, and oxygen has 6. So this one becomes a little bit trickier. I know that my oxygen needs to share 4 electrons. It needs to share 2 electrons because it needs to share 2 with this silicon. So if this oxygen takes these 2 and shares them, then I need another oxygen to share these 2 that are sitting over here by themselves. So I should have Si in the center with 2 oxygens, 1 on each side, and I'm going to have a double bond because silicon also needs to share 2 of oxygen's electrons. So you have to remember, let's see if I can change colors on this. You have to remember that oxygen has 6 electrons. So 6 of its electrons is going to look kind of like this. 2 of them have to be in between the silicon and the oxygen. So that gives me a double bond between them. I end up with SiO2. My formula is SiO2. Now what we did after that is we went in and we looked at page 15, 16, and page 17, 18. And this is, I believe this is the ionic one. And then this is the covalent one. So all you're doing is the same exact thing as we did here, but you're doing one separate page for ionic, one separate page for covalent. All right, so if you have any questions, make sure you post those on Sophia, and I will get back to you as soon as I can.